We already mentioned what MIDI is, and that is a protocol, standardized protocol that serves us to communicate between electronic instruments and computers and any other equipment, for that matter, that is compatible and serves that purpose. Now, samplers, I think, are the first thing we're going to talk about in a row of devices that actually accept MIDI signal and produce a sound. How do they do it? Well, a sampler would actually contain a piece of audio, recorded piece of audio, and reproduce it once it got a message from MIDI to reproduce it. So let's start with the simplest version of it. And you already seen this one. It's called Simpler. And we can use this Simpler to drag in any kind of a sound and trigger that sound, like this one, and trigger that using MIDI. Now we can send different notes, and I can change that sample. And we talked about that before, that it's really easy to change a sample. Now, of course, I can take in a sample of a drum, say this one, and play that. So triggering this sample with notes would actually produce for each note a different pitch for this sample. In Ableton, at a pitch of C3, that C note and on the third octave would produce the actual pitch of the sample at the pitch that it was recorded at. So this is the natural sound of that kick drum, how it was actually recorded, and higher, even lower, of course, than the nominal pitch. So that's a really easy way to explain it. A sampler takes a piece of audio and reproduces it once it gets a MIDI message to do that. Now this sampler called Simpler actually takes a piece of audio and reproduces it and actually maps it to all of the notes immediately. So at C3 we have the normal pitch, but if we play any note higher than that, we have the same sample played faster. So resampled to play faster, as if you took a turntable and span the vinyl faster, so everything would sound higher. This is what is done to this kick drum to actually sound higher. So you can see that it actually sounds shorter once I play it higher. Much shorter. If I play it lower, so see, that's longer for a bit. Now let's find a piece of audio that is actually an instrument. We can produce our own sample for the sampler. So I could load in a synthesizer of some sort. Let's say I'm really keen on Serum, and use Serum like this. So export this sound using a note C, of course. Why? Because note C is what it's actually going to be played at once it's loaded. You can always change that, but for the sake of this short demo, I'm going to export the actual note that once played out of the sampler with the same note is going to sound at the same pitch. It's going to be the same audio. So let's record that. I'm just going to freeze this channel to get this in audio. Nice, now I have this as an audio file. I can pull it downwards. I can make a new audio track, pull it on there. Okay, nice. Now I can unfreeze that, delete the Serum, and put a Simpler, and just drag this audio onto a Simpler. Done. That's it. That's how easy it is. So now I can play using this Simpler. I can play this audio. I can delete this altogether. So at the normal pitch, as you see, I can play this sample just as if it was from a synthesizer, but now it's already recorded. Now this means I'm using far less CPU resources. Not synthesizing the sound for each note pressed makes it much easier on the CPU. And not only that, I could have processed this audio before I put it into this sampler and used it. As you see, I recorded a really long piece of this sample, a long piece of audio actually. So now when I play a higher note, it will not be shorter. See, I can play a much higher one. It's just gonna go faster, but it is long enough for me to have it seem like a normal instrument. So this is one of the things you can do with samplers. Just use audio already recorded and play it like that. I could, of course, use a piece of audio like my voice. Just a moment. Let's record something. Now let's try this. Ba 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 ba. Okay. Let's record that. Bow. Bam. Okay. Now I can use one of these as an instrument for a sampler. Let's say this small part right here has been cut off. Okay. Now I have this sampler, I can just pull it there, and I have my voice to play with. Let's try that. Now, as you might have seen, in this sampler there is so many other functionalities we could use. We could loop this sample to play over and over and over once I press the key like that. So I'm just holding the key and it just actually plays that in a loop. As a note, I could even make that shorter. So you can make crazy stuff using samplers too. Now in this mode, as a warp, it's actually time stretching this sample for each note I press. So you will notice that for higher notes, it does not become shorter. But if I turn the warp off, it becomes shorter, as I've told you already. So you can compare this to the time stretching algorithms we already had when explaining audio clips. So without warp, it would actually be the resampling one, the resample algorithm, and with the warp, it would actually warp and time stretch this sample for each one of the notes to achieve that pitch of the note we are sending. Now, to go into more complex cases, we could use a sampler, and let me just load something of an instrument that the sampler already has in store, something that's already prepared for us. So let's say a piano of some sort. Let's say piano, bright production, mellow production, grand piano. Okay, let's load that. Now you see this piano sample for the sampler contains a long piece of audio, and I will explain what this is all about. Just let it load, because I see that it's still loading and drawing the waveform. Let's speed up this part of the video. Now when this is done, you can see that I can play the piano as if it was real. So a normal sounding piano made out of a lot of different pieces of audio. So particularly here, one note, then another note, and they were all recorded one after another. But in Ableton Sampler, you can actually choose only a region of that big audio file and map that onto a certain MIDI note. So let's see about the zones. We call these zones since these are actually mappings of that sample. So as you can probably guess, when recording a piano, it wouldn't really be realistic if we use just one note and time stretched it or actually played it faster or slower at some higher pitched notes, the piano wouldn't actually seem real if we really sped it up that much. So what can be done in exchange is recording almost all of the notes on the piano separately and mapping each one of those notes to a different key. So you see one recording from which we are taking notes from G5 until C7, and then the other one for the lower notes, much lower ones. You can see that. And then we have another one, which might be just a layer for that one. So maybe just a click. Most probably this piano has been recorded with a couple of microphones, one from the outside, one recording the actual hammer on the wires. So to make the piano seem realistic, it was recorded quite elaborately, and each one of those notes recorded separately was mapped onto a single note in the sampler, but much more on this you will be able to see in our sound design course. Now let's go into samplers a bit deeper. So if I took that vocal of mine that I recorded and used that as a sampler instrument, it would load this simpler sampler that has only one field, of course. And as you can see, I can employ certain things to this sample. I can process it. So I can edit some of the things. And let's say an envelope. Normally, an envelope, which we talk about extensively in our sound design course, an envelope is a time-dependent modulator that depends on our note on and note off messages that we get from MIDI. Now, to properly explain the envelope, I'm going to use a longer sample, that's for first, in our simpler, and I'm going to go into this visual representation of the envelope. To give you an example, this envelope has 3 time components and 1 amplitude component. Attack, decay, and release are time components, and sustain is an amplitude component. So, how does this affect our signal? Well, we said that once we have a note on message, so the note starts playing, what happens is we get our attack time happening, then our decay time happening, and if those two expire and we are still holding the note, that value of the envelope is going to retain itself at, let's say, minus 7 dB. And then once we let go of the note, then the release time happens. So let me demonstrate that by playing the sound and showing you with a, let's say, a larger attack time of, let's say, 500 milliseconds, 1.5 seconds decay, and let's say a lower sustain time and a longer release time. So let me play a note and demonstrate how this envelope is going to affect the amplitude, the loudness, the volume of the note. So I'm going to press it now. So as you can see, if I boost up the volume, of course, let's see how does that sound. So I'm going to press the note, the attack time is going to happen, the decay time is going to happen, I'm still going to be holding the note, it's going to retain itself at minus 19 dB, and once I let go, the release time is going to happen of 640 milliseconds. So let's do that. So attack. Now we're at the sustain, and I let go, and the release time. If I completely remove the attack time, making it effectively 0, there will be no attack time. So immediately once I press, the volume goes to maximum, and it's only the decay time that happens. Listen. So we have those two. If I make the release go away, so no release, 1 millisecond, just not to produce a click, an audible click, there's going to be no attack, so the volume of the sound, once I play the note, is going to start immediately. It's just a decay. It's going to hold at the sustain value as long as I hold the note, and then the release time is going to be 1 millisecond. So the moment I let go of the note, the sound is going to stop. So the moment I let go, there is no more sound. That's what the release does. Now, if I put the sustain all the way down, there will be no release, since the release is the time it takes for the envelope to reach minimum value from the sustain value after I let go of the note. And the decay time is the time it takes after the attack is propagated, of course, at the time it takes for the sound to go down to the sustain value if I continue holding the note. So the attack time is going to happen whatever the case is. If I set the attack time, it's going to happen anyways. But I can avoid having the decay time if I just put the sustain at maximum, since the decay time is the time it takes for the sound after the attack to go from the maximum to the sustain value. If the sustain value is already at the maximum, there is no going down, so the decay time is not going to happen at all. It's just going to stay at the sustain, and that's it. Now the release is the time it takes to go to 0 from the sustain value after I let go of the note. So let's put the attack time to 0. The decay time doesn't really matter right now. We can just put the sustain at the maximum. So once I press the note, it's going to be at the maximum value, and I let go, the release time happens. That's it. No release time. Stops immediately. More attack time. So there you have it. 3 time values and 1 amplitude value. Attack time happens anyway. The time it takes for the note to come to its maximum amplitude, since this is the amplitude envelope we are controlling, then the decay time it takes to get from that maximum to the sustain level. And if the sustain level is at maximum, nothing happens, of course. If the sustain level is below the maximum, then this is the time it's going to take to go from maximum to the sustain level. After that, once we let go of the note, since all the while we are holding the note, it's at the sustain level, sustaining the amplitude of the sound. Once we let go, the release time is the time it takes for the amplitude to reach 0 from the sustain level. If the sustain level is at minimum, there is no release. Release will not happen since there is nothing to release from. The amplitude is already at 0 after the decay is propagated. I'm still holding the note, but there is no sustain, so there's nothing to play. So I have the modulation that I can use on the amplitude of this sample. Of course, I have a filter. I can filter this sample out. So this is our frequency cutoff for the filter. It's a low pass filter. So let's hear that. I can use more resonance. And I also have an LFO that will help me move that filter up and down, back and forth. So I do have to assign this LFO to the filter, of course. And I can do that by going into the controls and assigning this LFO onto my filter, let's say, like that. So I can make it faster. Which, as you can see, can serve us to manipulate audio samples within a sampler and actually make an instrument out of it. So we can make a lot more processing decisions after the fact. And samplers actually allow us to play with the audio as if it was synthesized. So the role of this sample in a sampler is actually to replace an oscillator in a synthesizer. Many of the functionalities you can see in this sampler are actually the exact same copy of those you would see in a synthesizer. So filters, LFOs, modulating envelopes, all of this is available to you in a sampler as well as in a synthesizer. But these are just the basics of a sampler that you can use an audio sample, put it into a sampler like this, and use it to play a melody, even chords. Now you can play this sample in a loop, so turn the loop on and then choose a portion of the sample that will be looped, so the ending of it. So imagine if this sample was not as long. I could, for an example, if it was really short, do this. Have a piece of that sample loop infinitely so that the sample actually remains longer. So if I turn the LFO and the filter off, you can actually hear nothing else but the actual jump from the ending to the beginning. And this sample can last like that if I hold the note forever. To address that small jump from the ending to the beginning, I can use the fade option. So with careful manipulation, you can make this sample, even if it was short, you can make it last forever. So if you have long sustaining notes, some notes that you hold for a longer time, like pads or something like that, you could actually make it last longer. An easier version, of course, is always to just record a long portion of the sample and forget about looping. But if you had a really short one, you could always do this. Now, this simpler as a sampler has many more options, and we can deal with those once we get into our sound design. But we have a one-shot option where when you press play for this sample, it's going to play from beginning to the end. And it will have a fade in or a fade out. You can always choose that, see that? But it's always going to play from beginning to the end. We have a slice mode, meaning that if we were to enter any kind of a drum loop, let's say. So if I had a sample like this one, which I wanted to play in a sampler, well, higher. As you see with the loop function on, it's always going to repeat itself. It will be time stretch if the warp is on. But if I wanted to have each one of these small percussive elements as one sample, I could go into the slice mode and it would automatically detect, moved one. It would automatically detect all of these percussive elements and cut them up. Actually, without even cutting them up, just mark them so that I could play any one of those separately by just clicking a different key on the keyboard. So I could actually play each one of these, triggering a different note on my keyboard. So now this has all been divided for me automatically. So we have a lot more options in this simpler, as they call it, a simple sampler. But we have a lot of options to creatively use audio files. You can see a lot more of this in our sound design course.